Hi, Zayon. Hi, Nasisa. Welcome back. You can get started on the do now. Thanks for your nice message, Zayon. It's a bit quiet tonight, guys. It's already 1 minute past 5 and it's only 2 of you here. Do you know what's going on? Anyway, get started on the... Hi, Nolwazi, are you here?
Yes, ma'am.
Aha, there we go. Sorry, it's me. I'm not looking properly. Okay, hi, Nolwazi. Hi, Sihle. Hi, Marisa. Thank you so much for your lovely messages. So nice to be back with you again. Daniel and David, Naileti, Sinatemba, Jatuka, welcome back. All right, so hopefully you've got everything that you need with you. You've got your book that you're writing in and your calculator and a pen or a pencil. So we're going to get started on the do nows. I don't know if you remember these from the last time, from our last lesson, but we have to be able to solve exponential equations. So I just thought I would give you something like that to get started with. Okay, welcome Kelebogile and Tabasing. Nice to see you again. Jared, cool beans. I'm glad you're all back. Oh, a shame, Tutuka. Yeah, I can understand that. I also get the days muddled up sometimes, Tutuka. They just seem to go by so quickly. Okay, and in Tlafatso, I don't know if I said hello to you, so hello. No, in Tabaseng, we didn't have a lesson on Friday. It's only Tuesdays and Thursdays. So you didn't miss anything. Okay. We'd never have a meeting without you in Tabaseng. It wouldn't be the same. Oh, and Nazol's here and Kalisa. Welcome back. Yes, the math anxiety thing, it was a workshop. So that was something that was given by the mentors, just to sort of help you guys. Yeah, there we go. Thanks, Tula. It wasn't a maths lesson, but it was something that the mentors wanted to do with you just to help you with anxiety, if that's how you feel about doing maths. Anyway, I'm going to stop talking because I want you to have an opportunity to try and see if you can solve for X in any of the equations. Hi, Luke. Thanks for your nice message. Let's see if you guys can solve for X, at least in the green and the purple. If you can't do the red one, it's not the end of the world, but hopefully the green and the purple, and then we'll get underway with our lesson. Cool, Sihle, well done. All three. Hi, Katlejo, welcome back. We're just getting started on the do now, although it is 5:05, so we're going to have to crack on, as they say. Sihle, did you do all three? I don't know if you can hear me, Sihle. Oh, you did. Ma'am, I did. Not okay. That's fine. Not a problem. Okay, so Sihle, since you did the first two, I'm going to ask you, what did you get as your answer for X in the green question, in the first one? What did you get X is equal to? X equals 8. Did anybody else get X equals 8 for the first one? You can, Rabin, with pleasure. No problem. Anybody else get X? You got 4, Zayan. Okay. 4. There we go. Okay, so that was supposed to be the answer. If you recall from the last time that we spoke, we said, Marisa, you got 8. Okay, so have a look at the way that this is solved, Marisa and Sihle, and let's just have a look at where we've gone wrong, okay? Do you remember we said that when we were solving, Katlejo, you don't understand the parabolic graphs you started today. Okay, so what you need to do, Katlejo, is you can go and watch the lessons that we did on the parabola. So we've done 3 lessons on the parabolas, the first 3 lessons that we did on this course. Okay, so you can go and watch those. I'm sure Tula will be able to give you some more information about that. Okay, sorry. Yes, it's 4. That's quite right. Okay, so what we were supposed to do here is we were supposed to write, oh, hang on a second, I'm pressing on the wrong thing here. We were supposed to write 16. Well done, Sihle, that's great. As 2 to the power of 4. And now that we've made the bases the same, we can make the exponents again. Okay, so the same. Yes, Katlejo, I'm sure Tula will supply those to you. All right, so everybody that got that right, well done. Okay, so now for the second one, I'm going to ask Phoebe, what did you get for the second one? Did you hear me, Phoebe? You got 5 for some reason. Okay. I don't think that's what I got. Okay, anybody else? Anybody else got any other suggestions? I don't think it was 5, Phoebe, but that's not the end of the world. Anybody else got any other suggestions? Any other answers? What did you get for this one, Sihle? Okay, so David, you got 6. Don't think I got 6. Masisa, you got -2. Okay. Anybody else with an answer? Okay, so what was the first step with this question? What did we need? What did we need to realize before we could even get started on this question, grade 10s? What was the, you got -1, Nolwazi. Okay, that's fine. I don't think I got -1, but I can't remember. I think I got the same answer as Nosisa. Right. So what's the first thing that we needed to look at here? The first thing that we needed to look at, I hope you all agree with me when I say this, is, let's just change the color, is the 1. Okay. How would we rewrite 1? So we have to make the bases the same. So we have to rewrite 1 as 5 to the power of 0. Do you remember that? You got 3 rear bed square. Okay, no problem. All right, so the first step, guys, is to equate the bases, make the bases the same. So we've got 5 to the power of x plus 2 equals 5 to the power of 0. Now that the bases are the same, we can equate the exponents, which is what I'm busy writing on the screen right now. And therefore, x has to be equal to -2. Okay, so Nasisa, I got the same answer as you. Just check under there. Yeah, that was exactly it. Okay, does that make sense now? I know Nolwazi, you didn't get that. David didn't get that. Phoebe didn't get that. Does that make more sense? Are you happy with that? Rebetswe? Cool. Okay, so Zayon, you want me to explain how we got -2. Zayon, do you understand the first line where we've written 5 to the power of x plus 2 equals 5 to the power of 0? No problem, David. I'm going to do that for Zayon as well. You understand that, okay? So Zayon and David, as soon as you have made the bases the same, so that's this first step over here. Let me just get my pen back on again. This first step over here, this first line where I'm putting the little orange cross. Once you've done that, because you've made it base 5 on this side and base 5 on this side, what you are doing is that you're not looking at the bases anymore. Now you are just looking at the exponents. So we are saying, well, in this case, x plus 2 has to be equal to 0. And that's what gives us this line over here. All right, so if x plus 2 is equal to 0, we're going to take the 2 over to the other side, change its sign, and that's why x has to be equal to -2. Is that a little bit better, Zayon? David, make more sense? Excuse me. Okay, all right, so you've got to remember that, David, when you see 1, no problem, Zayon, pleasure. All right, so you've got to remember that when you see 1, it's a hint to write it with the same base, but with an exponent of 0. So because there's base 5 in the question, they wanted you to write 1 as 5 to the power of 0. Yeah, I suppose it is the same idea, absolutely. All right, yeah, Sihle. You're not looking at the 5 anymore, you're just looking at the exponents, no problem. All right, so now let's look at the last question just very quickly, okay, for anybody who did that. What we were supposed to do, the very first thing that we were supposed to do in question number 3. Oh, Rabin, you wanted to do this one. Sorry, I've just remembered. Okay, so Rabin, tell us what you got.
Ma'am, it is 2.7.
2.7. I got 3, Rabin. Okay, let's just double check my answer. Okay, so the first thing I did, Rabin, is I divided, because this, and I hope you guys knew this, maybe you didn't, right? Over here, what this means on the left-hand side, so the -3, and then there's the dot in the middle. In South Africa, that dot means multiply. So a dot is an instruction to multiply. So what we would do is we would divide both sides by -3 first. So -24 divided by -3 leaves us with +8. And now we need to write 8 as base 2. So 8 can be written as 2 cubed, and same story as before. Once we've made the bases the same, we can make the exponents equal to one another, and that's why x is equal to 3. Does that make more sense? You happy with that, grade 10s? Cool. Nazol, when you say what would happen if you multiply first? Okay, I'm happy to explain this one again. All right, hold on a second. Okay, that's fine. Hang on, guys. Sorry, we just want to explain this again because there's a few people that don't understand. All right, let me explain what this question means. All right, so we've got -3 multiplied by 2 to the power of x. So this dot over here, this dot that I've drawn in pink, it means multiply. So negative 3 times 2 to the x is equal to negative 24. So in maths, when you are trying to solve for a variable, you are trying to isolate the variable. You're trying to get it. Okay, Ravine, no problem. That's right, see there. 2 to the power of 3 is 8, 100%. That's exactly the principle that we're using here. So we want 2 to the x on its own. It's just like if we had 2x times 2 is equal to 8. It's a bit of a silly example. But the first thing that we would want to do is we'd want to get rid of this times 2 by dividing both sides by 2 first of all. Okay, so then 2x would be equal to 4, and then we could divide by 2 again and get our answer. So it's just the idea that whatever we want on its own has been multiplied by something else. So what we want on its own is the 2 to the x, it's been multiplied by negative 3. So we can get rid of the negative 3 and isolate the 2 to the x by dividing both sides by negative 3. So on the left, negative 3 divided by negative 3 leaves us with positive 1. Positive 1 times 2 to the x is 2 to the x. And on the right-hand side, a negative divided by a negative is a positive. 24 divided by 3 is 8. All right, and now you can do what Sihle said. All right, you can write 8 as 2 to the power of 3. So if 2 to the x equals 2 to the power of 3, it means that x must be 3, now that we've made our bases the same. Is that a little bit better? Yes, you would, Phoebe. You would. Do you mean 2x times minus 3? That's what I understood you to say, Phoebe. Is that what you meant? Yes, yes, absolutely. Then you would divide by the negative 3 first. Okay. All right, guys, let's crack on and get into our first question. All right, so please, I'm so glad you stopped me when you don't understand. It's no problem at all. I'm very happy to explain things again if it doesn't make sense to you, okay? Because that's the whole point. That's why we're here, okay? It's got to make sense to you and you know what you're doing. All right, so now let's have a look at the exponential function that is on the board, right? So we've been told that this is the exponential function f, and that's the diagram, that's what it looks like, and it passes through the y-axis at the point A, which is 0 and 1, and it passes through the point 2 and 9, okay? They want us to determine the equation of the function f in the form y equals a times b to the x. Now, we spoke last time about b and q, but we never really got a chance to speak about the letter A, right? So before we get into this question, let's just refresh our memories, okay? Do you recall that in any equation, any function, x and y are always input and output? That's it, well done, input and output. Okay, so an x coordinate that goes in and a y coordinate that comes out. Or in this case, 2 goes in and 9 comes out. Okay. Can anybody remember what the letter B represented?
Base.
Indeed. Okay, so B was the base. Right? You don't have to feel intimidated by the letter A. The letter A is simply a number that we are multiplying the base by. So in other words, if I can just go back to what we were doing in this question over here, all right? So this one that we've just done, okay? Let's just get it into the middle of the screen. So, sorry. In this question here that we've just gone through, can you see that the base is 2? B is the base, okay? And A is this number that it is multiplied by, Okay, so a is just a number that the base to the power of an exponent is multiplied by. So in the same way that we had 2 to the power of x times -3, -3 is like the a, the base is 2. It means exactly the same thing over here as well. Okay, so it's just a factor or a number that the base is being multiplied by. So a is a factor or a number. Okay. They've asked us to determine the equation in the form y equals ab to the x. They've told us an important piece of information here. They've told us the line y equals 0 is the equation of the asymptote. So what does that mean for us? The value of q is equal to what, grade 10s? What would the value of q be equal to?
0.
Good, well done, absolutely. So the value of q is 0 in this case. So we don't have to calculate the value of q. They want us to work out the value of a, and they want us to work out the value of b, right? We have to do this by substitution. So now we go back and we look at the points that they've given us, right? The first point that they gave us was 0 and 1. So if I write y equals ab to the power of x, see here, they normally call it q. I mean, theoretically, they could call it any letter that they wanted to. It could take any letter, but normally they call it q. All right, so yeah, if you see plus or minus something at the end, then you know that that's the asymptote. Okay. All right, so the first thing that we want to do, pleasure, the first thing that we want to do is sub in, right? So if we sub in the first point, where should I put the 1? In place of the, you can unmute or speak to me, in place of the y. Well done. Yes, good, perfect. So in place of the y. And that means I'm going to put 0 in the place of the x. Okay, now something really, really important happens here, okay? And that's why we have to know our exponent laws so well. We spoke about this the last time that we were together. What, I'm putting a circle around it, what is b to the power of 0? What is that going to give me?
1.
Well done. Good, excellent. So it's going to give me 1. So in other words, I've got, good guys, well done. I've got 1 equals a times 1. So that means that the value of a has to be 1 in this case. That's right, Celia. Anything to the power of 0 is 1. All right. So first we had to work out what the a is. Now we have to go back and work out what the b is using the other point that they gave us. So what we would do is we would sub in and we would say y equals 1 times b to the x. Okay. Now we want to look at that other point. Remember the other point that we were given that lies on the line was this point over here, the point 2 and 9. So now I'm going to take the 9 and I'm going to sub it in the place of the which letter? Where should I put 9?
Y.
Y.
Good, good, well done. Okay, so 9 equals 1 times anything is not going to change its value, so I don't have to write times 1 again. And then in the place of the x, I want to write 2. Okay. So now b squared is equal to 9 is what I've got. Remember, your base cannot be a negative number. Remember, your base can be bigger than 1, or it can be between 0 and 1, but it can't be 0 and it can't be 1. Do you remember that from the last time? So what are we going to do to both sides of our equation now?
Divide by 9, I think.
Divide by 9. Okay, but this is b squared. Square root. Okay, Phoebe, that's it. Well done. You're on the ball there. All right. So that's quite right. So I want to take the square root on the right, and I want to take the square root on the left. Okay, so when I am solving an equation that has a square in it like this, that's something that I can do. All right, square root the left, square root the right, and that means that b is going to be equal to 3. Are you happy with that, grade 10s? Does that make sense? Okay. Good stuff. Okay, so that means for us, good, I'm glad. You must just stop me if it doesn't. All right, so that means that the equation of this function, it is the line y equals 1 times 3 to the power of x, but we don't ever have to write 1 times. Okay, so it's just the line y equals 3 to the power of x. Okay, everybody happy with that? Okay, next question. Now we want to determine the equation of the function h of x if this function is reflected in the x-axis. Actually, let's change that, sorry. We didn't talk about that the last time, so we're not going to be able to do that at this point. Let's reflect it in the y-axis. Does anybody remember what happens when we reflect over the y-axis? When we have a function, what changes if we reflect over the y-axis?
The y-intercept.
Say that again, please.
The y-intercept.
Is the y-intercept going to change if I reflect over the y-axis? The sign, yes, Riabets, where the sign of what? Yes, and Tava saying, well, the sign of what? What's going to change? Is the sign of y going to change, or is the sign of x going to change? Phoebe, don't the values become negative for x? Yes, Phoebe, they do. All right, so everybody else, this is what Phoebe is saying here. All right, so I'm just going to move this over and draw another graph. Okay. My terribly skew axes. Thank you for being so patient and not judging me. All right. And our graph looks like that, doesn't it? Okay, so this is the graph y equals 3 to the x. So if we reflect it over the y-axis, it's now going to be a mirror image of itself. Okay, now I'm going to try and draw this, but it's not great on this writing pad. All right, so it's supposed to, whoa, what is that? It's supposed to look like that. Do you remember last time we spoke about graphs that were J-shaped? So here's your J shape. And then when we reflect it over the y-axis, it's not J-shaped anymore. It's now C-shaped. Very bad C, but anyway. So as Phoebe had said, when we reflect over the y-axis, x changes sign. All these x's over here that were negative are now positive. And all these x's that were here that were positive are now negative. So quite right, Phoebe, when we reflect over the y-axis, let's write that down. So when we reflect over the y-axis, because this is important for you guys, okay? So write this down. When you reflect over the y-axis, it is x that changes sign. Okay, so if x was positive before, it's now going to be negative. So, sure, Zayon. Do you want me to repeat everything that I was talking about from the beginning?
Yes, please, ma'am, because I just arrived right now.
Okay, all right, no problem.
Yes,
so, just what I was saying about the y-axis. Okay, so when we reflect a function, okay, imagine you could pick up the pink line and you could take it and you could flip it over like that, and then you could let it go, right? That's what you've done when you do a reflection. So if something is like this, and then you flipped it over, it's like a mirror image of itself. So the green line is a mirror image of the pink one over the line, the y-axis. Okay, so these values over here that I'm now putting in orange, these values here, these x values here, these were all positive, weren't they? Because x is positive in the first quadrant. But this part of the line has now been reflected over here in the second quadrant. So these x values that were positive have now become negative x values. Right, and these ones over here that were originally in quadrant number 2 are now sitting here in quadrant number 1. Right, so there's been a reflection over the vertical line, okay, the y-axis. So when we reflect over the y-axis, it is x that changes sign, okay, from positive to negative or vice versa. So what does this do to our graph? Well, it now becomes, sorry, I should write in green again. Our graph changes like this. Okay, x changes sign. But when you are in grade 10, you're not allowed to leave things with negative exponents. You've got to write them with a positive exponent. So this goes back to our previous lesson where we were talking about negative and positive exponents, because you've got to be able to do it here as well. Can anybody tell me what it is that I can do so that I don't have a negative exponent anymore? How can I rewrite this so that x is not a negative exponent? Any ideas? Even if it's wrong, don't worry.
Can
Share
you
your
say
ideas.
can you say y equals 1/3 to the power of x?
That's fantastic. Was that you, Rabin?
Nizole.
Oh, okay. Sorry. My apologies. That is 100% perfect. Well done. Okay, hundreds. I'm really, really pleased that you knew that. Okay, does it make sense to everybody else? All right, so we would use the reciprocal. So we would write 1/3 and change the power of the exponent. Okay, and then this goes back to what we were saying about when b is a value between 0 and 1, and when b is a value that is greater than 1. Okay, so here in the green, your base is a fraction between 0 and 1. Here in the pink, your base is a number that is bigger than 1. Okay, for both of these graphs, remember, we are working above the asymptote. Okay, so remember that A that we saw before? For both of these, we haven't had a discussion about that yet, but for both of these, A has to be positive. All right, so if you have a look in front of this 3 over here, do you remember there's an invisible? Times by 1. Over here, same story. There's an invisible times by 1 in front. Okay, but don't worry about that too much for now. Okay, so let's go back. All right, so when we reflected it in the y-axis, we ended up with y equals 3 to the minus x, which needs to be written as 1/3 to the positive x. Okay, good stuff. Do you remember any questions at this point? Sorry, before I carry on. Okay, Sihle, no problem. Thank you. All right, so grade 10s, do you remember what the word range means?
It means y value.
It does. It does. So the y values. So now they want us to write down the range of h of x. Okay. So going back and having a look. Now, remember, h of x is now our green graph. The green graph is h of x. And it is equal to 1 over 3 to the x. How are we going to work out what the range is? Where does that come from? What do we need to look at? Does anybody know? Shall I go through this again quickly? So Daniel, quite right, it is the y values, 100%. Okay, so if you look at this function, grade 10s, it's coming all the way down from positive infinity. So it comes all the way down in this direction, okay? Yes, from negative infinity, but Nizol, does it go to positive infinity? Because look at what happens as the line gets closer and closer to the x-axis. What happens? It starts to curve away and then it gets closer and closer and closer and closer and closer, but it never, ever, ever gets to the x-axis.
Ma'am,
So,
I think it's, sorry, ma'am, to interrupt. Ma'am, I think it's because of the intersection line here. That's why when it crosses here, when it crosses the C-shaped graph, when it crosses this line here, it becomes a negative infinity, if I'm not mistaken, ma'am.
so you're right. It comes, it's not going to go to negative infinity. It comes all the way from positive infinity. And don't worry about interrupting me. I've got no problem with that at all. So it comes all the way down from positive infinity. So positive infinity is that way, okay? Negative infinity is that way. All right, because the y-axis is a number line, zeros in the middle, and then the numbers above the y-axis. So over here, there's 0 that I'm just busy coloring in at the moment. Okay, so when we go in that direction over there, we're going towards positive infinity. When we go in this direction over here, we're going towards negative infinity. Everybody happy with that? But there's a problem because your x-axis is like a barrier that the green line cannot go through, okay? The x-axis is the asymptote. Remember, at the end over here, the bit that we can't see, all right, is that at the end, we've got plus 0 because this graph has not been shifted up or down. So that means that the value of Q is 0. Remember, we spoke about that in the beginning. Okay, I asked you guys what the value of Q was, and someone told me that it was 0. So if the value of Q is 0, it means that the graph can never ever, y can never ever equal 0. All right, it can never ever equal 0, which means that our range, our set of y values, y is always going to be greater than 0. Okay, so that would be the range in this particular case. Grade 10s, if you had a function like this, let's say, oh, okay, Phoebe, I'm hoping that makes sense to you. I'm hoping it makes sense to everybody else. So I'm just carrying on going here. Interrupt me if you need to. I really don't mind. Let's say you had y equals 2 to the x plus 1. Okay, Katlejo, I'm so sorry that you're feeling a little bit lost, but do watch the videos, right? In this case over here, so if we're now looking at this function here, what's the value of Q? Q is equal to?
1.
1. Good, well done. Okay, so Q is equal to 1. So that means that the range of the function 2 to the x plus 1, the range is going to be y is greater than 1. Okay, so your range grade 10s always comes from the Q value, whatever the Q is, right? So in this case, both of our functions are sketched above, right? So they're going to get infinitely bigger, but they can't get any smaller. So that's why for the function that we had drawn on the board, the green one, the range has to be y is greater than 0. As far as this one that I was writing in purple over here, the q value is 1. So the range is y is greater than 1. Okay, is that making sense to everyone? Can you give me a thumbs up if that's all right? Okay, good stuff. Any other questions? Good. Okay. Any other questions you want to ask me? Okay, so now it's your turn. Right, so here is a function. Right, and we need to work out the value of a, like we did before, and the value of q. Right, so remember, q is the,
Excuse me, ma'am.
just say again, please. What does q represent?
The asymptote.
The asymptote. Good, excellent. Okay, so what is the value of the asymptote in this question?
-4.
Beautiful, beautiful, well done. Okay, so now I'm going to stop there and I'm going to let you guys try this on your own. Okay, so I want you to sub the -4 in the place of the q in your equation up here. You've got your calculators. You're going to sub in this point next, right? And then you're going to work out the value of a. I'm going to give you a couple of minutes to do that, so I'll stop talking now. Okay, and just try and see if you can do it on your own. Okay, so when you think you've got the value of a, you can let me know. You can say done or thumbs up or anything like that into the chat. Okay, so I'm just checking in grade 10s. I'm sorry to pester you. How's it going? Going, not going? Okay, Phoebe, you say good, I hope. Have you got an answer for A yet, Phoebe? Okay, so let me call, I'm not picking on anybody. I'm just obviously reaching out to you and I want to talk to you and I want you to talk to me as well. Kelebohile, did you manage to work out a value for A? Nizol says you're done, but it doesn't look right. Okay, well, Nizol, what did you get? What did you get as your value of A? Don't be shy, Nizol. Okay, is that 1/289,668? Okay, I can see why you thought that wasn't sure. Yeah, it's supposed to be, Daniel, you got 0 for A. Okay. A cannot be 0, unfortunately. Otherwise, it would make that whole term equal to 0. No stress. Thank you. 1/4 or 0.25, Phoebe says. Any other answers that anybody wants to share? I took a quick sneak peek at, at what I got. Okay, so let me show you what I had done here. Okay, grade 10s. I'm sorry if this was difficult. I didn't mean to make it impossible for you. I just obviously wanted to give you 1/5, and Tab is saying, okay, let's try and figure out where you guys are getting these fractions from. Okay, and Tab is saying, did you say that Q was equal to -4? Did you all do that? Did you say that y equals a times 2 to the x minus 4? Was that your first step? Like that? So we subbed in the -4 because we want to, if we know the asymptote, we want to put that in first. Okay. And now, yes, okay, cool, Nizol. All right. So we would first sub in the asymptote. Okay. Now we need to sub in the x and the y. Where am I going to put the -3,625? Is that the y or is it the x?
The Y,
Y.
ma'am.
Indeed. Okay. So what I did is, okay, so I just converted it to a mixed number, but even if you hadn't done that, it doesn't matter. You could still write it as a decimal. That's fine. Okay, so we've subbed that in, and then in the place of the x, we've subbed in -3. Right? What would we need to do next? What would be the next step? So you would take your -3 0.625, and you would have to add 4 to that. Okay, because what we're going to do here, grade 10s, take the 4 over to the other side. Quite right, Daniel. Okay, so this -4 over here, oh, shame, David, no problem. I tell you what I'm going to do. Instead of, I prepared the answer for you guys. Let me just do it again on the side here. No stress. We can do that. Okay. Nizol, oh, I forgot did you forget the X? Did you forget maybe to sub the X in? Okay, so David and anybody else who's feeling lost and confused. David, if you know the value, oh, you forgot the comma. Ah, okay. All right, well, I'm so glad you figured out where you were wrong. Okay, so David, if we know the value of the asymptote, we want to put that in first. So we've got the function y equals a times, remember the dot means times, 2 to the x plus q. So we looked at the picture and we all agreed that the value of q would be -4. So we would come along and we'd say, well, then y is equal to a times 2 to the x minus 4. Okay, so we've got to sub that in first. Then, David, we need to sub in this point that's given to us over here. They are telling us that our x value is -3. And they are telling us that our y value is -3,625. Okay, so we're going to replace y with -3,625. -3, Marisa. I think I got +3. Yeah, I got +3. So almost there, Marisa. Well done. Maybe when I go through it now, you'll be able to see maybe where you made your mistake. All right. Where were we? Okay, so we want to work out the value of a. So a times 2 to the power of -3 minus 4. So now I can't remember who said this. Yes, it was you, Daniel. Daniel, you said take the 4 over. Quite right. So now, grade 10s, what you can do is pick up your calculator. All right. On the left-hand side of the equation, you've got, put this into your calculator, -3.625. Remember, when the 4 goes over, it's got to change its sign. So we've got -3.625 plus 4. When you press plus 4, what do you get as an answer?
0.375.
0.375, absolutely. All right. Now, if you write that as a fraction, as something over something else, okay?
3/8.
3/8, absolutely. Okay, that's what I want you to do. I want you to write it as 3/8. Good, Sihle, quite right. Is equal to a times. Now, 2 to the power of -3, how would we rewrite that with a positive exponent? Do you remember our negative law that says if we've got a negative exponent? Yes, Sihle, quite right. Keep going.
Is it 1/3?
It's 1/2 to the power of +3. So remember,
yes, sorry.
No, it's no problem at all. Okay, and that's where the 1/8 comes from. Can you see Sihle put 1/8 in the chat? Okay, that's perfectly correct. Is everybody happy with that? Right. So now we've got 3/8 equals 1/8. And when we have the same denominator, we can say, well, the denominator is the same in both, And that means that A must be equal to 3. How does that feel? Does that make sense? Is it okay? It's a difficult question, this one. Okay, Sihle. What about everybody else? Nazol and Tabaseng, Daniel, Tutuka. How do you guys feel? David, Marisa, Rabin, sure? Okay, so you understand, Phoebe, you didn't change 2 to the negative 3 to a positive exponent. Okay, all right. Kelebochile, Nasisa, Jared, it's understandable. Okay. Can we do another question? All right. There is 5 minutes left. These lessons go way too quickly.
No.
So yes, I did actually have another question for you. You can
Yeah, I
see
do
over,
need WhatsApp. Yeah.
you can see here. Do we cancel the X? Sihle, what do you mean when you say, do we cancel the X? Which X? Okay, so yes, because remember, we've already substituted in a value for X here. Remember, X was equal to negative 3. So at this step over here, Sihle, when we subbed in our Y, remember we subbed in our X, so we haven't got X anymore. We've got minus 3. Okay, and that's where the 1 over 8 came from, because we wrote 2 to the power of negative 3 as 1 over 8. All right, no problem. I'm so sorry, grade 10s. The time just goes by so quickly. There is this question over here, all right? But unfortunately, I don't think we're going to have time to be able to get through it. So what I can do perhaps next time, because you see it's exactly the same sort of questions that we've been talking about, where write down the range, determine the equation, sketch the graph. I wonder if this would work. Tula, do you think it would be possible for me to ask the grade 10s to do this question for Thursday? Can they try this on their own and come on Thursday with it marked?
Yes, of course. And it can
Okay.
be done, I guess, instead of the homework or in addition to the homework on the app. So yeah, I think it's very much possible.
All right. Okay. So then if they've got access to this video, they could then come back and come and have a look at this question and come and try and work out the answers.
Yes, and they can take, I guess, screenshots now, but I'm aware
Okay.
you are on a hurry. So I guess they can come back to the video and I'll let them know at the end how they can access the video.
All right, that's great. Okay, so grade 10s, if that's okay with you, all right, take a screenshot of this. Is there any revision on this topic? Was your writing a test on Thursday? Phoebe, you should find stuff on the app, but Tula will be able to explain to you where you need to go. Okay. But this question will be a good question for you to try. No problem.